Okay, let's do level 2 banked turn fun. So with friction now, what we're going to have is we're going to have the same kind of situation. You're going to have your gravity, you're going to have your normal force, but you're also going to have your friction force. We're going to pretty much always go as fast as we can, which means the friction force will be helping to hold us down the hill. Alright, now one thing to keep in mind though is your centripetal force is still going to be pointed inwards. Now there's two parts to your centripetal force. There's this part and this part. Alright, so this part of your centripetal force has two pieces now. It's got the same gravity force, right? This one and the friction force together. Alright, so these two together make this one here. But this one still shows up because this means that you'll have a net, I'm going to just say up force, right? What is that? Force. Okay, because your force normal is not equal to your gravity perpendicular. Okay, this guy right here is not equal to this one. Your force normal is going to be bigger. Okay, because your net up force is going to be your force normal minus your force gravity perpendicular, because it's going up, right? So this one has to be bigger than this one. Where's that extra force coming from? It's because the road is pushing the car to help turn. Does that make sense? Because it's like, you know, this what's happening. So the road is pushing on the car to help turn it more, you know, because it's lifting up the car. Whatever. Okay, let's do some practice. So what's the max speed of a 10-meter turn with a 30-degree banking and a coefficient of friction of 0.25? Alright, so here's the turn. It's 10 meters. We want to know what's the highest speed, so V is equal to something. And we've got this triangle, 30 degrees, because we want to be nice to you for the first one. Get that all out of our system. Alright, so we're going to have mg. This guy right here, this is 30, so this is going to be mg cosine of 30, and this one is going to be mg sine 30. I wonder what that is. This is going to be your normal force, which we'll come back to. Okay, and then this one right here is going to be your force of friction. We're going to have a force of friction, which is equal to mu times your normal force, and this one is going to be your force centripetal. Right? Your force centripetal is the way it was before. So we're going to have this guy right there, and this guy down right angle, and this is going to be your 30 degrees. So this one will be FC cosine 30, and this will be FC sine 30. Alright? So hopefully we're feeling okay with that. Hopefully. Alright, so we want to know what the speed is. Well, what do we know about, so we're gonna set it up the same kind of thing right there. So we know that FC cosine 30 is going to equal mg sine of 30. But that's not all. He's got help now with the force of friction. Force of friction, remember, is mu times your force normal. Alright? Because these are all the forces that are pointing downwards. Remember that this is not a real force. It's just the net force. Okay? Which is the centripetal force. These are the forces that are acting this way. Okay, so far, so good, I suppose. Alright, so FC, rewriting it, because we have to work with force normal now, is equal to mg sine 30 plus mu times force normal. What is the normal force? Well, your normal force is going to be, well, let's set it up in a way that makes more sense. This guy is them subtracted, right? So FC sine 30 is going to equal your normal force minus your mg cosine 30, right? Because this guy is going up the, out of the pavement, minus this one going into the pavement. All right? That'll equal your net force, which is right there. So we just got to solve this for force normal. So force normal is going to equal Fc sine 30 plus mg cosine 30. Boom, boom. All right. Are you intimidated yet? Anyways, so what do we got to do now? Now we just got to plug in what Fc is. We know what Fc is. Fc is mv squared over r cosine 30 is equal to mg sine 30 plus mu. I'm going to distribute the mu. mv squared over r sine 30 plus mu mg cosine 30. Alright? Now, it looks really intimidating right now, but we know what most of these numbers are, and a lot of this stuff will just cancel out because here go all the m's, right? All the m's. There's an m in everything. Boom, 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 boom. Those are all gone. And what are we looking for? We're looking for the max speed. Well, do you want to solve for v, or do you want to just plug in numbers and get it? Oh, who's afraid of a little algebra? Who am I kidding? Let's solve for v. So everything with the v squared is going to the left. So v squared over r cosine 30 minus mu v squared over r sine 30 is equal to g sine 30 plus mu g cosine 30. Alright, so far so good. Alright, undistribute the v squared, so v squared times cosine 30, can I just do over r, minus mu sine 30 over r is equal to g sine 30 plus mu g cosine 30. Right, so that means that v squared, go all the way over there, is equal to g sine 30 plus mu g cosine 30 divided by cosine. I guess you could throw the r's up top. I'm not going to worry about that. For r minus mu sine 30 over r. Ta-da! And square root that. But anyways, let's type all that into the calculator because we know what all those values are. Mu is 0.25, r is 10, g is 9.8. Okay, gonna need some parentheses for this one. 9.8 sine 30 plus 0.25 times 9.8 cosine 30 and parentheses divided by parentheses cosine 30 over 10 minus 0.25 sine 30 over 10 end parentheses enter. So I'm getting a v squared is equal to 8.37. Right, after typing that in to the to the square root, and then we're going to have a v is equal to 2.9. Right, so far so good. That should make sense. It's not very sticky, and it's whatever. Okay, hopefully that helps. Let's do one more. There's only 2 of these because boy are they a mouthful. What's the coefficient of friction needed for making an 11-meter turn with a banking of 10 and a speed of 22? Alright, I'll bet you this one has a high number to it, because you are going fast. Alright, so it's 11 meters going this way at a speed of 22 meters per second. Alright, let's see if you can set it up. 10 degrees. Alright, mg cosine 10, mg sine 10. Friction normal. FC 10. So this is going to be FC cosine 10, FC sine 10, Fn F is equal to mu Fn. Alright, and then Fn is equal to FC sine 10 plus mg cosine 10. Okay. Alrighty, so now let's see. So this is what I'm looking at here. So FC cosine 10 is going to equal the two downwards ones together. So we're going to have mg sine 10 plus mu times force normal. So mu times the force normal, which is FC sine 10 plus, I'm going to distribute the mu automatically, mg cosine 10. Alright, so there's the setup. Now let's see here. We is solving, I guess we can plug in centripetal force here. So we're going to have mv squared over r cosine 10 is equal to mg sine 10 plus mu mv squared over r sine 10 plus mu mg cosine 10. Cross out all the m's. They all go bye-bye. Alright. You could plug everything in to get numbers, but bah, who's afraid of algebra? So we're going to have v squared over r cosine 10 minus g sine 10 is equal to, I'm going to abbreviate combine a couple steps. Hopefully that won't scare you too much. So I moved, what is it, this one over? No, these ones stay the same. Alright, whatever. I switched the order on you accidentally then. Plus v squared over r sine 10. I undistributed the mu, that's what I did. I switched the order because I wasn't paying attention. Alright, so mu is going to be v squared cosine 10 v over r minus g sine 10 divided by the big one, g cosine 10 plus v squared over r sine 10 is equal to, alright, calculator time. V is 22 squared divided by 11 times cosine 10, I need a parentheses, minus 9.8 sine 10 divided by parentheses 9.8 cosine 10 plus v squared over 11 times sine 10 and parentheses enter 2.4 sticky stuff. no unit because it's a coefficient of friction. Hey, and that's that. Wasn't that fun? Don't worry, I'm sure you'll have questions about this fun stuff. Let's see, we're going to do some review tomorrow, and then we're going to have a test at the end of the week, so you don't have to wait over break. All right, I'm sure you're excited after looking at these two problems. We'll see you later.